Okay, Santosh, so let's go ahead with you. So you want to go for the snap mock of which subject?
Strength of material, sir.
Okay, so you're preparing for what?
I'm preparing for junior manager interview, which is in DFCCIL.
Which is in?
DFCCIL, Dedicated Freight Corridor.
DFCCL, okay.
CCIL.
CCL, okay, no issue. So, and you are from which background?
I'm from civil engineering and I'm currently doing structural engineering in masters.
Okay. Okay, Santosh, so let's go ahead with your snap mock for the subject of strength of material.
Yes, sir.
So tell me the scope of this subject, strength of material.
Scope of like by using the strength of material, we can analyze the structures and we'll find the shear force, bending moment, and so we can design the structures using those values.
What is shear force?
Shear force, according to definition, it is the sum of the forces, transverse forces from a section, like sum of the algebraic sum of the forces from a section. Either it is left or right of the section.
Okay, give me a few examples where you think that shear force will be acting.
Shear force, like if a beam is subjected to loading, consider a simply supported beam, and if a point load is acted up at a center point, then
what else?
Sir, what else?
What?
Any force which acts transverse to the direction of the
example. If it is not transverse, then?
If it is not transverse, if it is normal to the surface, then it is axial force.
So other examples of shear force.
Shear force examples. Shearing between two surfaces, kind of.
Give me a concrete example. Okay. So what is the what is the nature of bending stresses?
Nature of bending stress. It makes the beam to undergo deflection in a curvature form.
Okay, well, that is okay. But what I am saying is, what kind of stress is it? What kind of stress the bending stresses are?
What kind of stress? Flexure stresses.
No. Is it shear in nature? Is it tensile in nature? Compressive in nature? Torsional in nature?
Bending stresses can be like if a beam is subjected to point load from like at a midpoint, then lower bottom of the beam is in the tension and upper bottom of the beam is in the compression. So it can be both.
Okay. So I think in case of dedicated freight corridor, right, in that particular project, you know, you're going to have a lot of bridges set up right over there. So what kind of supports normally you provide at the end of the bridge?
At the end of the bridge, I think they are simply supported, sir, upon bridge.
Simply supported.
Yeah. With the column, huge columns.
Will they be able to support your bending loads? Can simply supported beams support these bending loads?
Yes, sir. They do.
Okay, they can provide resistance to bending.
They can, and compared to fixed supports, they have a minimal, like they are of less resistance to fixed support. Their capacity is less when compared to the fixed supports.
Okay, let's say if you have to choose the shape of that particular bridge, what kind of shape will you prefer?
Bridge shape. Like in a transverse direction or in a longitudinal direction? Are we talking about?
I'm talking about the shape of the bridge.
Shape of the bridge. It is a rectangles.
Have you heard about beam of uniform strength?
Yes, sir.
What is it?
Like it is a like we make a we make a beam with respect to the bending moment. If there is a moment and we have depth over there, if there is a decrease in the moment, then we decrease the depth along the moment, so that it does not have extra area of unnecessary area. Yes, sir. And it contains uniform strength throughout the length of the beam.
So have you heard about flexural rigidity?
Flexural rigidity. Yes, sir. Yeah.
What is it?
It is a product of modulus of elasticity and a moment of inertia.
So what does it indicate?
It indicates that rigidness of the structure. If it is if a structure is flexurally rigid, it means it undergoes minimal deflections.
So how it is different from Young's modulus? How EI is different from Young's modulus?
Young's modulus says that it is the slope of the stress strain, actually stress strain diagram, and EI is it indicates rigidness of the structure.
No. If you have to compare between these two for the same structure,
okay.
So what difference you are going to have in the interpretation?
In unit wise, EI is a mm cube. Modulus of elasticity indicates the elastic nature of the material, and it indicates the rigidity of the material. EI.
How different?
Elasticity is like ability of material to stretch to some point, like up to elastic limit, and rigidity is like resisting the deformation under the load.
So that means if you will multiply by I, it will become rigidity. If you will multiply Young's modulus with the moment of inertia, it will become rigidity. Earlier it was elasticity, right? That's what you're saying.
Analytically, it was that.
New.
Yes.
Okay. So, do you know what columns?
Yes, sir. It is a vertical compression member.
So let's say it's not vertical, it's inclined. What we will call it?
We call it a strut, sir.
So at what load this column is going to fail?
At critical loads, beyond critical load.
And what is that critical load?
Critical load is something which makes the column to buckle. For a longer column, according to Euler's theory, critical load is numerically formula 1 pi square EA by L square.
Let's say I am having a rectangular column,
Yes,
long
sir.
column.
Yes, sir.
So in which direction it is going to buckle?
In the direction of where moment of inertia is less, IX or IY, which has moment of inertia is less, in that direction it will buckle.
So why it will buckle in the direction of minimum? Why not maximum?
Why? Because moment of inertia represents that ability of body to rotate. If it is less, it allows the body to rotate in that direction.
Okay. So have you heard the term called as strain hardening?
Yes, sir.
What is it?
It is a point, like it is a stretch shown in the stress strain diagram of mild shell during tension test. It indicates that even after yield point reaching a mild shell, it has ability to undergo deformation and has ability to resist more load. Like it undergoes molecular rearrangement during that region material.
Okay, you talked about the tensile test. Can you let me know what kind of tests we can perform in UTM?
Tensile test.
Only tight tensile test.
We can even do compression test. I think.
That's all.
I'm not much aware of this. Other tests.
Okay. Okay, Santosh, let me just now give you the feedback.
Yes.
Now see, you're not confident in answering. Okay, just revise this subject. When do you have your interview?
On July 26th, sir.
July 26th, still you have time, right? Today is 4th.
Yes, sir.
So, see, like I ask you what is shear force, you were not able to tell properly what is shear force.
Okay.
You started explaining we are having a beam and then we are applying transverse load and all that. Shear force is any force which is acting parallel to that section.
Okay.
As simple as that. Take any section, apply a force parallel to it. We call it as a shear force.
Yes.
Examples, you got stuck up. Only beam you could think of. Right? Why beams? You could have any member. You just think of where this load is parallel to that section. Even if you are applying a tension in a member,
Yes.
you could have shear force.
Yes.
In complex stresses you have studied.
Yes, sir. Yes.
So you should have been able to tell that. Or maybe torsion, applying a torque, shear is getting developed.
Yes.
So you have to give the examples, properly explain. You have to explain it to them properly. Nature of bending stress. You were not able to understand the meaning of nature of stresses, but at the end when I gave you the hint that okay, whether it's tension or compression, nature means how does it, what kind of force or stress is it? Either it can be tensile or compressive.
Yes.
Supports normally at the ends. Okay, just go through it. What kind of supports? I think in structures you may have studied. See the different kind of supports that you're going to provide in different kind of bridges. Beam of uniform strength. Okay, you were able to answer. Flexure rigidity and modulus of elasticity got confused. See, Young's modulus is a material property. It depends upon the type of material that you're using. But when you're multiplying it with this I, that means you're multiplying a material property with the geometric property. I is a geometric property.
Yes, sir.
So you should have said it is not something like that elasticity becomes rigidity. It will convey the same meaning. It will say that, okay, how easy or difficult for you to bend that material. But that will not depend on the section, Young's modulus only. That is the material only, but that will also depend upon the
Cross section.
That cross section also.
Yes.
Right, material property. So that is how you have to differentiate. That means that shows that okay, whether you have understanding of these concepts or not. Column, I think you were able to explain. Hardening, strain hardening also. I asked you one example question that of tensile compressive. See, in UTM you can perform both the tensile as well as compressive, and also the plain shear stress, simple shear stress also. A simple shear test can also be performed. You just need to make an arrangement over there, and you can apply the force where it is trying to shear that material.
Yeah.
Simple shear, not torsion. Torsion you cannot perform because in that case you need to rotate it. So, but simple shear definitely you can perform. Okay, so I think just revise the subject properly from the point of interview. Just go through the box and just watch that video on strength of material, complete video. And
I have been through that video, sir, which has been uploaded in the YouTube. But I know this subject, but I lack communicating.
No. You are not lacking communicating. Communication will come out when you have. Okay, go for a few more snap mocks. There is no issue. That communication part will come handy. Don't worry. That you will improve when you will go for the snap mock.
This is my first interview.
No issue. First time it may happen that sometimes you are nervous and not able to present yourself well.
Yeah.
Just go through it, revise it, keep on revising. Just watch that video, other content also. If possible, watch the different snap mocks which are available on the panel, so that you will get the idea of different kind of questions that could be framed. And just whatever notes that you are having, just revise them in parallel.
I have been through medicine notes completely.
Whatever notes that you are having,
Yeah.
just whatever notes that don't rely on the notes only. That's what I'm saying.
Okay.
If you rely on the notes, those notes are based upon your exam.
Yeah.
Where you had to crack the exam. Here you're not for the exam. Here you had to crack the interview. So those notes can only be helpful only for revision. Just go through them and try to, but you have to relate it with the other part of which is given to you on the panel from the interview point of view. Otherwise, they're not going to be helpful. If you rely only on those notes for interview, then they in itself are not going to be helpful. You have to club them with other things which are provided to you on the panel. Okay.